Theorem 1.25 Intermediate Value Theorem. If f is continuous on the closed interval ab, and z is a real number such that f of a is less than z and less than f of b, then there is a c in ab such that f of c is equal to z. I will pause because I want you to be mindful of what this theorem is saying. So if f is continuous in the closed interval ab, what the theorem is telling us is if there is a real number between f of a and f of b, we are sure to find a real number in the open interval ab such that f of c is equal to z. This is the graph of the function defined by f of x is equal to x times sine of x. You know that sine of x is a continuous function. And in fact, sine of x is continuous for all real numbers. It is continuous in the set of real numbers, and so with x. And so the product of two continuous functions is going to be continuous. I hope that you are not kind of overwhelmed by the graph of this function. You know that sine of x is a sinusoidal function. And you know that x here, if x were a constant, it will tell you the amplitude of your function. The amplitude is the vertical distance or vertical length of the graph of your function. But because this is not constant, this is not constant, so it has the effect of producing this in the amplitude of your function. So we shall zero in into a small region of this graph, and we shall look into this part of the graph. So let us pay attention to the closed interval 0 to pi over 2. Our function is continuous in the closed interval 0 to pi over 2. Now, f of 0 is equal to 0. F of 0 is 0 times sine of 0, which is 0. What about f of pi over 2? What is the value of our function when x is pi over 2? So it's going to be pi over 2 times sine of pi over 2. And you know that sine of pi over 2 is equal to 1. So the value of our function when x is pi over 2 is pi over 2. Now we will locate a z, a capital letter Z, between 0 and pi over 2. And so in this case, what we have here is 1 is between 0 and pi over 2. This is our capital Z in our theorem. What does the theorem tell us? If f is continuous on the closed interval ab, and if capital Z is a real number between f of a and f of b, then there is a c, a small letter c, a real number c in the interval or open interval ab such that f of c is equal to capital Z. So this means that we are sure to find, because our function is a continuous function in the closed interval 0 to pi over 2, we are sure to find a real number c between 0 and pi over 2 so that f of c is equal to 1. Corollary to intermediate value theorem. A corollary is somewhat of a theorem that accompanies a major theorem. It's like it's the immediate consequence of a theorem. And this is the corollary to the intermediate value theorem. If f is continuous on the closed interval ab, if f of a times f of b is less than 0, then there is at least one c in the open interval ab such that f of c is equal to 0. I will pause. But I will not go to the next slide right away because I want you to read again this sentence carefully and be mindful of what the corollary to intermediate value theorem is telling you. If f is continuous on the closed interval AB and if their product is less than 0, so this means the product of f of A and f of B is negative, then there is at least one C in this open interval such that f of C is equal to 0. If f of C is equal to 0, C is what you call your x-intercept. Let us go back to f of x is equal to x times sine of x. But we will pay attention to the intervals pi over 2 to 3 pi over 2. F of pi over 2 is equal to pi over 2. Now let us pay attention to b. Let us say our b is 3 pi over 2. F of 3 pi over 2 is negative 3 pi over 2. Okay, why is that so? Well, it's a simple case of evaluating your function when x is 3 pi over 2. If x is 3 pi over 2, sine of 3 pi over 2 is negative 1. And so when you multiply that to 3 pi over 2 multiplication, the product is negative 3 pi over 2. So what you have here is f of A is positive. It's above the horizontal axis. This is below the horizontal axis. It's negative. So if you were to take their product will be negative. Now, what does the theorem tell us? What does the corollary to intermediate value theorem tell us? Because this function is continuous in the closed interval AB, we can produce a graph so that this point, we can connect it to that point, to the point that is below the horizontal axis. We are sure that our graph will intersect the horizontal axis. And so that is where we shall find the value of C, the small letter c, so that f of c is equal to 0. If we have a continuous function in the closed interval AB, and if their product, if f of A times f of B is negative, that's what it means, it's negative, then the graph from A to B is sure to intersect the horizontal axis. It is sure to give you a value of C so that f of C is equal to 0. That is your x-intercept. The theorem is telling you there is at least one C, so that implies there could be more than one. And that is what is shown by the graph of your function if we are to look at the longer interval. We are working on the same function. F of x is equal to x times sine of x, but we are now paying attention to a longer closed interval. So let us pay attention to this point. Let us say this is your point that corresponds to f of A. It's below the horizontal axis. It's negative. Let us say this point corresponds to your f of B. So the y-coordinate of that point is your f of B. It's above the horizontal axis. Their product is negative. So the theorem is telling you there is at least one. There is at least one x-intercept. So when you say at least one, there could be 2, 3, 4, or even more than 4 x-intercepts. And in this graph, in the interval 10 to somewhere like 27, these are the x-intercepts.